All right, so I really want to do the Z-axis today. I don't have the camera set up, so I don't know, but I do have this. This is pretty cool. I bought this. What is it called? HX711 chip. And we're going to try to do something fun, which is basically, okay, on here we are going to attach, here, all right, we're going to attach this thing. I'm going to bolt it in. Let's see. Yeah, that'll be fine. Okay, we're going to bolt that on, and then we're going to... So first off, let's just CAD this out, right? Or wait, hold on. Let's see if we can get a... Let's just do it. I feel like it's so easy to do this. Watch how easy this is. Alright. Load cell. I foresee some complications in this. So, okay, let me preface why we're doing this. So, I'm building a pen plotter, and the board that it's mounted to is not flat. I know it's not that flat, but I want to get a sense of... I mean, I don't know how I would. My plan is to just use whatever numbers... Basically, okay, this thing at all times gives me a number. I also can take... Ooh, this is going to be interesting because... I'm not sure I'm going to have... Because, okay, all the pins are taken. Well, I think not all the pins are taken, but I don't know how to get them. We'd have to look at the... let's see, where's that CNC Shield 3.0? I think it's on here, actually. What is it? There's a link on here somewhere. info.protoneer.com/1. Technically, we could just go in and figure out... I think it's this. I need to link this. This is so nice to have. I don't know if I... Let me go get my laptop really quickly and we can see. Okay, but let me just look. So, this is the shield. Okay, it's a Z-step. Z end stop. So, okay, so those are both digital pins. So technically we could... But I guess... Okay, wait, hold on. How do I log... Like, because there's no memory on this thing. So let me just ask... Okay, well, here's what I could do. Here's what I could do. I write... Wait. So, okay. So the sort of easiest way to do this is to reflash the Arduino with no GRBL. If there's no GRBL on there, then we have to sort of know all the settings of the thing about step. We basically just need to know steps per millimeter, which is not so hard because I think it's 5. So we could just, if we know that, then we could just write our own little program. What's funny is I'm realizing that I've only ever manually stepped stepper motors on MicroPython. I don't even know how you do it. I guess it's the same thing. You just write a value to 1 and then you delay for a little bit. So, Okay, so that's one way of doing this. So if we're... Okay, so if we're... So right now we're tackling... Okay, let's... Oh, I gotta, we did this. I would have to go push my freaking code. This is the problem with using to-do lists for, whatever. Okay. Does GRBL let me read, since it's hooked up to an Arduino, does it let me read the value of a digital pin? Yeah, see, that's what I'm saying, though. I feel like reading sensor data. Oh, this guy's done an encoder setup. You could just divide it, but see, I'm kind of, I don't know. I could hack GRBL, but it's like, what's the freaking point? All right, so I think that the only thing that's coming to mind. Oh. Yeah, but see, it's hooked up to. Wait, But is it actually hooked up to... So this is the shield. Oh, and that's a pass-through? But what is it hooked up to? Let's see, A5. A5's got to be on here somewhere. Reset, ground. Oh, it's hooked up to reset. Wait, no, it's not. SDA, SCL. Wait, that looks like an I2C line. There's so many pins on this thing. I don't even know. Okay, so here's the... See, what's up with these 4 stepper motors? Is this actually hooked up to anything? A step? It's actually not even on here. Coolant. Where's coolant go to? Cool. See, these are all on, but I don't want to use the analog. Can you use the analog pins as digital pins? Oh, really? That's kind of cool. So then maybe that's what I can do, is I can use... So, okay, so hold on. Let's read this. Reading and input via built-in features, yeah. So if I do this, you can see the limit switch for sure. If you connect a sensor to the Z probe pin, The thing is, how do you do this again?
Sub business ding its data pin to pin 7, its clock pin to pin 8, and connector pads, and thus connecting its data pin to pin 7, its clock.
So it's I squared C. That's kind of specific. Let's see. Has anyone done this? Well, this looks cool. Abrasive quality testing machine with manual sanding connected by technique. Oh, that's cool. 2-axis gantry. Is essential that the downward force be applied by my spindle onto the workpiece remains constant. To do this, I would like to use input from a load cell to control actuate the vertical displacement of the z-axis. This load cell will be placed under my T-slot plate where the workpiece is placed. Does anyone know if this is possible? This is my first time using GRBL. Why GRBL? GRBL is for complex coordinate geometry. Sounds like a simple back and forth or basic pattern combined with pressure control. That's a simple Arduino sketch. All right, so you know what? That's what we're gonna do. I mean, he's right. I was hoping to be able to control my axes as well as. So okay, hold on. So. All right, so I think. All right, so let's come up with the steps then. But how does it? You know what I could do? Okay, I could do this. Let's see. Wait, hold on. Okay. So I have 2 Arduinos. Yeah. Okay, I think I got this. But how do you synchronize? No. You just open up 2 serial commands. This is so easy. Why am I making this harder than it is? Okay, this is what you do. Okay, this board is just for the controlling the axis. Okay, all right. I'm glad I read this because this is exactly what I'm going to do. So I'm going to solder this board up. First, we're just going to see if we can get this thing working and start reading some data from it. And then I guess I'll need to do some CAD. Alright, so why don't we do the CAD right now, and then, okay, so let me just write down the instructions. So here's what we're going to do. I'm just going to do this, load cell.md. So here's how we're going to measure the surface. So we're going to, okay, so it's a Python script that opens 2, serial ports. One will incrementally send a grid of G code, to the GRBL controller. Then, technically we should know its position, so whatever we get, but we could also, if needed, could also send. Is it just one question mark or two? I always forget. Is it just question mark? Oops. No, that's the... Oh, it's all up here. But wait, can we just show the... This is what I was thinking of. So we could parse this. So wait, first let's just home it. Alright, so it should be at 0, 0. I don't know what BF is, but we could parse this. So let's stop that, paste that. So we could also send a question mark or whatever and parse the string. Is that going to show up weird? Okay, so then the next step is going to be then on the second it will and log the x, y force data. Alright, so we have a plan and it's guaranteed to work. So we just need to, so the steps are going to be do that. So okay, so then the actual steps: 1, CAD everything up. Yeah, get the load cell working. 3, write the code. I guess what we want to do is get stepping the Uno from Python. And then how are we going to power this thing? We're just going to power it with... So I need another USB cable. I need to go find another USB cable, but that should be easy. Okay, and then I guess one thing that's going to be a little bit weird is we get the other Uno to read the load cell. Or I guess that's already there. Okay. So yeah, so this sounds fun, I suppose. I think though the CAD is going to be a little bit weird because basically, so it's not just the load cell, but we also need to CAD up this chip because I'm not going to run this. I kind of want to keep this on the thing and then just send over the 4 that we need. Even that's going to be kind of annoying. I gotta do a desk cleanup, man. Okay. Alright, well, we're gonna have to do this anyway, so, you know, the hardest part is always starting, so let's just start. There's some unknowns in this, because this is new for me. I'm guessing this is square. 12.64. 12.67. $75. What did I say? 12? 12 point. Alright, so what did I say? So let's just start with this. So this should be really easy. Actually, I want to do it as a sketch. So let's just do this. Or should I? I don't know. Okay. Load cell. Width. Load cell length. Let's say hole diam. Or let's say mounting hole diam. LC. Let's see. Center bore diam. Let's see. LC bore max diam. Alright, so let's just start measuring. So this was, let's just put it exactly as what it was. It was 12.75. We're going to round up slightly. This was 75. This is, actually, I wonder if we can, I'm pretty sure, yeah, it's this. Does it give you a drawing? 12.7. Oh, perfect. See, this is what's great. Okay, 7. Oh, that's perfect. Okay, so we should actually just, okay, so is there a way to add documentation to this thing? I feel like there is, right? Isn't there a way to, like, not create drawing, but just, like, make a, like a documentation thing? Just like a PDF or something? I guess you have to upload a PDF and that's what you do. It's kind of weird that you can't just do a markdown. Let's just say, okay, so this is the product. How do I open this? What the hell is going on? Open image in a new tab. Oh, shit. Okay, wait, hold on. Does it say I squared C? Four leads, easy use, plus drive voltage. Direct output is a voltage signal due to force changes. Yeah, that makes sense. It's annoying because I honestly wish that the trend would be just switch to 3 volts. I love those ICs that could take 3 volt logic and 5 volt logic. It's just great. I don't know if anyone's tried that because I much prefer to write MicroPython. Okay. It would be cool to get it hot and see. Oh wait, hold on. Let's try to get it with a. Let's try to get it with a Pico. Let's see. Fuck yeah. Let's this is sweet, man. Clock pin, data pin. Yeah, it's I squared C, right? Hold on. I don't know what that even means. Oh, I feel like that's such a detail. Okay, in any case. Set gain, that's fine. Okay, read returns the actual read average. Oh, that's cool. This guy wrote some nice code. All right, we're going to try to get this to work. It seems like, look, if this is, all right, let's just you know, I want to finally do this cuz this has bothered me for so long. Actually, let's do it on my phone. I'm a little nervous about all this stuff. Okay. Now I can star repos because I hate when I can't star repos. All right, so yeah. All right, so we got a plan. Pico's just so much easier to drive. So okay, so I think the all right, so let's get the CAD because we already got this. So it says that it can handle 2.6, so we should be able to do everything. Current consumption. We really don't care about current consumption. It doesn't say I squared C, but if there's a clock in data, then let's just ask. Oh, okay. It sends 24-bit raw ADC data in serial. Alright, so it's like some custom sort of thing. Let's also just do this. I should be able to use a Raspberry Pi Pico too, right? I don't even know what this means, bit banged. Yeah, we ain't gonna do all that. So how do I use this thing though? I forget how to use these libraries. I'm pretty sure that I have to like this is the GPIO one. So I should be able to like machine preempt SPI pin. This is the SPI test. Min max. What the frick? Why are all these libraries always so janky? That's a great picture. Alright. But I think we went the simplest one, right? The GPIO. Oh. Maybe I should just try to not use a library. Alright, so let's get the CAD done. Let's just keep with the program because there's a lot of stuff to do. Wow. That's a cool little device. I guess this is a standard way to do this, is you have the top and the bottom. Alright, so we need to think about this, though. I think I am going to use a Sharpie like normal. Alright, let's get the CAD done. I'm being so lame. Alright, so boreholes center dist or something. Okay, so let's just pull this thing up over here. You know what? In terms of like all the products I've bought on Amazon, which is I don't know, depending on who you ask, is a lot. This is pretty well documented. You got the mechanical drawing, you got the electronics, you got a pinout. You know, it's not that bad. This thing is pretty sweet, actually. All right, so Let's see, but you know what? I want to actually get the caliper measurement on the thickest part of this thing because it has this goop on it. It's 14. Should not matter because I think oh no, actually wait, hold on. Okay, so that's interesting. Well, but it's going to be hanging off of it, right? So the start of the goop is like 30 in, so we can kind of avoid the goop. All right, I'm still processing what's about to happen. Okay. And then what is the diameter of, what is this? 0.8 200. I don't even know what that means. I guess that's the length of the wire. These wires are not 200 millimeters, bro. Maybe they are. I guess they are. That's wild. Okay, so let's just so we keep this up. Just okay, we can keep this open. Let's close all of this stuff. Wait, I closed the Amazon link? Fuck. Did I? No, I didn't. It's over here. Okay. Alright, so let's just get this done. I don't know what I'm doing. Alright, so 12.75, 75, hole diam. These are 4. Center bore diam. That, I guess we have to measure because... I don't think it says. Open image in new tab is just broken in this browser. Dude, what the hell? $10. 10.5. Let's do 10.5. Okay, so the center bore diam is 10.5. Okay, this is 7. I love that it has tolerances on everything. I mean, yeah, that's awesome. Okay, then whole space short LC whole space long. I don't know. Terrible names, but whatever. So this one's going to be 10, and then this one's going to be 44. Alright, I think we have all of the stuff here. So we could just make all of those... but you know what? Is it even worth it? Like, why go through the effort of doing all of that? So this is going to be LC len. This is going to be LC width. Okay. Then we're going to have 1, 2, and then we're going to do a hole here. Okay, and then we are going to mirror it, but let's get this down first. So this is going to be 10. Oh, wait. Short. Okay. And then what's the distance actually? Uh, 3.75. Let's see. Okay, 10 plus 44 plus 10. So 60. What is that? 64. 75 minus 64 is 11 over 2. 5.5. That seems right, actually. Okay. So this is going to be LC len minus 2 times LC space short over 2. What? Wait. No. LC len minus... Oh, wait. Dude, how bad is the expression viewer in this thing? This is like the worst. Okay. This is the worst. I don't know who designed this. But this is the worst. Can you imagine having... Let's see. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Can you imagine typing all your code into 15 characters? Okay. I really need to log all the things that are absolutely garbage about Onshape. Okay. Onshape bad.md. Okay, so first off, in the expression writer section for putting a dimension, this is the longest string viewable without scrolling side to side. It's 15 characters. Okay, so that's one. Onshape is the best CAD, and I would still rate it a 3 out of 10. It is best... Okay, so this is 2. It is best practice to, instead of using hard-coded numbers for dimension... Whatever, I don't care. It's the fact that you... It's the dimension press 1, then backspace, then type the var name. Okay, 3, I understand why, but the 1 millimeter plus 1 erroring makes sense, but I really wish when I just need to get something done, I could have 1 implicitly default 2 millimeters. Okay, so those are my 3. Just like Onshape is like literally the worst program ever made. Cause like how the hell am I supposed to how the hell am I supposed to actually edit an expression like this? It's just so bad. It's like I have to like go over here, look at it. Oh my god. It's so freaking stupid. And that's about what I measured, so that's good. Oh, that's not right. Wait, that doesn't look right. It looks like it... Oh, maybe that is right. Oh, but you know what? This is the... Oh, that looks closer to... So that is pretty much the whole part, right? I'm not going to CAD out the cables, but this is basically what we need. I guess we need a little spacer there, right? Do we? I say no. I say we're just going to put it into something. I think what I'm going to do is instead of some weird stuff, I am going to build a part around these. Okay, so okay. Alright, let me get a notebook. Do I have paper anywhere? Let me get my backpack. I'm also going to commit my code, I think, if my laptop's not dead. Actually, why don't I use my whiteboard? I really wish I could make a whiteboard stand. I wonder if I could do it out of a box, because I really want it to be like up here. Or actually, I want it to be like... This is where you want it. Ooh, maybe I could do this. Okay, so the part is going to look like... So we have... So I mean, the simplest thing here is we're going to let's see, how thick is this? 12. That's plenty long. I mean, it would be okay. So let's just design a new part. $42.1. I wish this would tell me the actual variable. Oh yeah, hold on. No number reverse search or express search type thing. I see the number 42.1. What variable is that? What I have to do there is I have to go like this. This is not so bad, but it is pretty bad. 15CL. So it's L. Okay, so let's just make the part, right? I don't know why I'm being such a baby. Okay. Okay, so we need to design two parts. Where did I put the load cell? Alright, this is gonna be fun. I'm actually excited. Um. Okay. So let's say this is going to be the load cell. Okay, so I'm pretty sure I want this to be like 30. And this is going to be like MGN 15CL. 15C? That seems right. Okay, so now we got to get these holes correct. So this is wide care. So let's just get this sketch done. Oh, that's the wrong one. It's going to be this sketch. Yeah, so we just want to, so this is 3.5. Okay, so we want to copy that. Okay, so we're just going to get that down. Wait, what happened? Oh, because I'm still in the sketch. Okay. Okay, wait, but this is not going to be right. You know what? I feel like let's just do it on here, right? It's tangent there, but not tangent there. How is that possible? What? Sure. Okay, so what we're going to do is do this. We're going to extrude this. Except, wait. We want... But not that one. Hold on. So we want to do... Wait, we're not in the sketch anymore? Okay. Extrude this by like... I don't know, let's make it small. Oh, but see, you know what? Here's what we're gonna do. Hold on. Okay, wait, hold on. That's so goofy, bro. That is so silly. So what we want to do is go to this variable studio, and then we want to take. Will this work though? Copy table. Paste it. Okay. Copy this. Now what we're gonna do is go to here. Huh! It put name in there. Wait. Let's just delete this one. See, okay, but then what happens? So here's what we're gonna do then. We're gonna see if this works. This is so janky, but we're gonna delete. We're gonna delete all of these. You can't select multiple, it's so annoying. So in the documentation of this, I like add a prefix, and LC means load cell. Okay. Then we should be able to go to load cell, insert variable studio, other documents owned by me, params. And then let's see, does this break everything? All right, cool. So now there's one of truth, and it's all these. Cool. So now we can refer to that in multiple places. So basically, oh wait, but then we have to go. Okay, so the idea is we extrude this. It's going to be a tapped hole. Anytime I can, I'll make it through and tapped. It's a dangerous place for the water bottle. Okay, so let's just do it. I think that this part is fine. That's all it needs to be, really. That's quite literally all it needs to be. Perfect. So these are 4. We're going to need the M4s. Hold on, I gotta do something. Or actually, hold on. Dude, autocorrect is still somehow so bad. Okay, so this is the part. This is all we need. So now what we're going to do is... So, hold on. This is going to be Y-care belt mount. We're going to delete this. You can just delete this. Why can't I delete it? What? Why can't... Oh, because it's in progress? They have a check for that? That's interesting. I guess that makes sense. Okay, where are we here? We need that. We don't need this. Okay. All right. Okay. That's all we need. So we're just gonna go over to the assembly. Insert the part. So, okay, wait, so hold on. What we want to do, before we do this, actually, we want to take these two, delete them. Oh, wait, okay, do we want to modify that? Let's go find that. So let's hide this. Get that. Just not gonna do these. Alright. Wait, but what happened here? That's okay. What was it? It was 5.6, so 3.4. M3 counterbore. It's just like the worst, bro. It's just the worst. I hate this thing. How can anyone write expressions in this thing? Dude, I gotta get someone from Onshape on the phone and be like, does anyone realize that this is actually stupid? M3 socket hole minus M3 hole over 2. That's what it was. There we go. And then no tangency. Alright. All right. So we're good. Jeez, where's my head at? All right. So now that we remove the counterbore, we can go in here, and then we don't need a counterbore that's that top face. That's like that. And then what we want to do. So how much distance do we need? We're gonna need like a. We're gonna need a pretty long bolt, like a M4 by 20. I actually want to buy an M. Okay, now other documents. Not tinycnc, load cell, create a version in load cell, create. Let's make that public in case anyone needs a load cell. Okay, now we just need to design one more part. And let's actually, I shouldn't have closed everything so hastily, because I want to change the appearance of it. It's aluminum. So it's just assign material properties and all of that. This is assign material, aluminum, assign appearance. Nice. So that's kind of too dark. Kind of too dark. Why don't they have like a nice one? There. That seems good. That seems like aluminum. Okay, let's make another version. Material and appearance. Okay. So we're good there. Let's just leave it open just in case there is something. Let's just cool. Okay, so what I'm planning on doing is having a little clip. Okay. Let's just draw it on here. Who cares? Where's my head at, bro? Okay, so let's just do this. So we're going to extrude this. Okay, wait, but what we want actually is... I guess we'll just do like this. And then this will go... I don't know, do we want to make it 5? 5 is thick, but it'll work. So, okay, so let's just dimension it to be 5. Okay, so then we're going to take this and this. Extrude it by 5. Oh, oops. It's a new body. And this is going to be just the pen mount. Okay, and then I am going to actually just make a mid-plane. Actually, do we have a mid-plane? No, we need to make a mid-plane. Plane. Okay, so we got the mid-plane. Let's get rid of all these planes. View this plane. Then we are going to draw on here, sketch. Okay, we're going to use this line. Oops, let's just use this line. Okay, we're just going to extrude this up to face. It's an add, merge with, pen mount, up to face, up to plane. Is there a way to up to face? That, yeah, plane counts as a face. And then we're just going to mirror this, I guess. Let me think about that. Sure, why not? All right, so we're going to mirror this features, this and what? What? Did I get something wrong? Oh, why don't we just do a part mirror? Part mirror, let's just do this part mirror around this mirror plane. And then can we do a join? Is that a join? It's just bool. Pen mount part 3. There we go. That's the part. Wait, will that work? That'll work, right? So it's going to stick out like this. So now we just need to sketch onto, I guess it's onto here. Wait, is this the wrong, this is the wrong face. Now we're going to sketch on here. We're going to do our classic, it's like a circle, and then a circle, and then do we have this dimension? We must have this dimension. I'm just going to make it 15, 4, because I just remember all these magic numbers because I'm sick. And then the thing here is that I'm pretty sure we want this to be tangent. Isn't that right? Then we just extrude this, add up to face this. What? Hello? Wait. Oh, you know what? Yeah, merge scope up to face this face. What is going on? What is going on? I think it's because... Oh, there we go. Should we just do one? Let's just do one for right now. I only ever use one anyways. So let's do plane. Not line angle, but tangent. And then let's get that point right there. Okay, let's sketch on here, here. They just do it in the middle, right? Okay, this is going to be Jesus. M5 tap. What? Wait. Oh, because it's not in here. That's so annoying. Alright, whatever. Let's just make... It's going to be M... Okay, fine. So it's just 5 millimeters minus M5 minus tap hole reduction. Is that right? Are we? Is that what we do? I feel like that is what we do. What's up, Will? Bro, okay, so here's what we're doing. I'll show you what we're doing, because we are doing some hype stuff right now. I don't know if you're still watching, but... So I got this load cell. And I never used one of these before. But I kind of always wanted to. Well, I don't know if I've always wanted to. I love the idea of them. They're really cool. Anyway, so what we're going to do here is... I have... Let's just show it on CAD because I don't really have the camera set up. So I built this. And so the idea is we're going to put a pen on here. Is that going to go through? I guess we could do one through. The other one... Well, I don't want to replace this part. That's the main thing, is I can't replace that part. Anyway, so what we're going to do is we're going to put a pen on the end of this thing. And by putting a pen or something, I would like to use a pen. So we were going to do... We're still going to do a pen plotter, but this is sort of like an intermediate sub-goal because I don't have a good feel for the surface finish of the wood board that this whole thing sits on a 2 foot by 2 foot by 3/4 inch wood board. Actually, you know what? I have an idea. Why don't we actually finally CAD up the board? Just do this really quick. I've wanted to do this for a while, but I didn't have a good constraint, but now I actually do have a good constraint. And we can just measure where it's at. So rename board. Okay, this is just going to be... This is going to be a rectangle like this, and this is going to be 2 feet by 2 feet. Extrude this by 0.75 in. Okay, let's change the... So first off, this is going to be wood board. Okay, we're gonna so basically what I'm worried about is I don't know what the surface finish of this thing is. So okay, first off, let's assign material. Wood. They have a whole bunch of woods. What about my wood? I don't know. Oh, it's like plywood. Do they have ply? What is ply? What's but is there plywood? I don't see plywood. Bro, I'm not manic. Who said I'm manic? A little shitty said I'm manic, bro? Come on. That's messed up. Ply, I don't know. Let's just pick wood. Who cares? Who cares? It's not like I'm doing it's not like this CAD even has simulation. So, who really cares? Edit appearance. That's gross. That's not what it is. That's a little closer to what it is. Maybe like that. That looks pretty good, actually. I like that. Okay, so now let's just measure the distance here. Okay, 46, 47. All right, so we don't have a mate connector though. Okay, so I guess we want to sketch onto here. Let's see. We need to actually check on X motor mount on this. Which sketch is that? That's. It's not that. 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 It's this. Okay, 7. So it's 7 from the edge though. That's okay. All right, so it's, and then how far is this in? Is that true? That's pretty far. Okay, so it's gonna be that 47 plus 24. Oh, guys, also my chat is like kind of bugged sometimes. So let me open up my phone because usually nobody's in here, right? So one day that'll change, but for the most part, nobody watches this shit. So if you're chatting, now I can see it. Okay. What are we doing here? We're making holes in the wood board. Okay, so we need to just do. I only want one of them. Okay, so first off, this is going to be like, jeez, what am I doing? What did I say? It's just an M3, I think. Just make it M3 hole. Okay, that's small as hell, bro. Okay, so then this is going to be, what is it? Where's the board? Or where's this? So this is up to here. So it is literally going to be 7. So that is actually going to be 7. And then here is 24 plus 47. 24 plus 47. All right, nice. I was like actually pretty close. So let's just I always do extrude, but actually where's hole? I've been meaning to do hole. Honestly, hole is stupid. No, I want to do hole and some real stuff. Okay, so we have this, and that's just my locator for my mate connector, because otherwise I have to do an offset, and I don't really want to do an offset. So now in the assembly, we can do this. This actually makes pretty hype. I've never done this before. Insert board. Look at that big-ass board. So this is, like, pretty sick. Okay, wait. So it's this to here. Okay, and then we just need to do that. All right. That is actually what this thing looks like. It's pretty sweet that is really what it looks like. Dude, this thing is awesome. Dude, I love CAD speedruns. Dude, there's this guy, Too Tall Toby, bro. I fucking love Too Tall Toby. Those CAD speedruns are sick. And you know, nobody uses Onshape. nobody in those CAD speedruns ever uses Onshape. They always use some weird shit like Inventor or some nonsense. I don't know. Looking good, man. Okay. Well, we'll see. What's up with these? What's up with these? Somehow that got destroyed. I don't know what happened there. What happened there? It doesn't come with the slider, mate. It just fucking stayed there. What? That's goofy as hell, dude. That doesn't make any sense. Okay, so this is what it looks like. And basically, this board is not actually that flat. So what I'm going to do is attach that pen to here. So let's just finish that up. So we have this, and we're just going to do this. You have to do extrude, remove, up to next doesn't work when it's on a tangent plane. So you actually have to do up to face. So there we have that. I'm wondering if we're going to need clearance here. I've actually had some really good luck recently. But the thing is, this part, printing this part might be kind of weird. I guess I'm going to tap both of these. Honestly, why did I do this whole mirror thing? I don't know. Like, okay, because let's think about this. Yeah, if I do it like this, then I can't print it nicely. So I think I'm just going to make this like 10 millimeters and then make this go to there. All right, so let's just try to delete this mirror. Delete this boolean. Let's make this extrude. Let's delete that extrude. This extrude is going to be 10. Then this sketch, that sketch should be fine. This extrude is the only thing that's weird because up to face, we're going to do it on this face. That seems fine. I don't see anything wrong with that. And what's this sketch about? Oh, geez. Okay, wait, hold on. Oh, wait. Oh. Is that vertical? Does this have a vertical? Oh, it is. Okay, so then all we have to do is, like, when we move this around, I'm just gonna delete this and do it again. So when you go like this, wait, why don't I have this line? I just drew this line. What happened? 5 millimeters minus tap hole reduction. Oh, what? Wait, what? What just happened? That was weird. Okay. I thought I hit the X or something. Okay, so that's what it's going to look like. So then I can print it from the top and it's not going to be so janky. Alright, so that's a better part. And then let's wonder about how tall it needs to be, because I might need to make it lower. So, top of load cell. Oh, and now we can measure stuff to the ground hella easily, because we have this big-ass board here. That's 100 millimeters. How long is a Sharpie? Like 100 millimeters. Okay, so let's just insert that part. Blood goofy ah. Blood goofy ah. Okay. So, I say we just insert Sharpie from the other one. Oh. Is there anything else that I need? Okay. I don't know what that was about. I feel like that's really high. I feel like that's higher than the old model. You know why? Because we're building up. This is such a janky little shim, bro. So we got rid of this counterboard, but we shouldn't have even gotten rid of that counterboard because I'm not going to reprint that part. I'm only going to print this part and this part. All right, let's just insert the Okay. I mean, that's the worst, though. That's not gonna... I mean, that's... Maybe it'll fly. It's not great, though. No one could say that's good, because that's not good. But it's fine. It's fine. So we're going to just try this, because I just want to get something done and tested by today. So we're going to export these two parts. Take out those bolts. These are M4. I think we did... Actually, you know what? Let me double check, because I'm pretty sure that this is wrong. So, okay. I'm pretty sure that's still good. All right. So that's good. I'm wondering if a pen is the best thing, though. Like, what you really want is like a roller. And you want it rigid. Should I make this longer? Let's just make it longer so that I get some more rigidity in there. Because we should... I'm not going to tap this, but we should be able to crank it down really tightly. So that means that we are going to go back to load cell. This extrude... Not that extrude. This extrude is not going to be an up to face. It's going to be blind. And it's going to be like 40. Let's look at it. Oh, this is the worst about doing this stuff, is that then you got to do this, 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 this. It's not that much better. We're going to change this hole to be down further, and we're going to add more of them. The thing is, then this can flex at this interface. I wonder if I should have used this line in the extrude. Let's see if we can do that. Just to make it a little bit stronger. But then it might not fit. I don't know. It's this extrusion. And instead, it's this sketch. What we want to do is we want to use this line. Okay. And then in this extrude, we also want to do this. Then maybe it's a little bit stronger. I mean, it still looks weak, but maybe it's a little bit stronger. Just because then it's not going to deflect pressed up against this thing, perhaps. Perchance. This is 4, right? Okay, that's good. What happened, though? What broke? Right, so what we actually want to do is... Ugh, God. Just delete all this geometry. And just make this all relative. Okay, so we just want to make this like 10. And then it's just... We'll see. Okay. So now we gotta make a version. This is so brutal. I don't know why I do this to myself, seriously. It just always gets so tangled. How does that look? That looks pretty good. I'm pretty pleased with that. But let me just, if this is an M5, I don't know what the M5 hex head looks like. In any case, I'll be back in a minute because I gotta take a shit. Okay, the motherfucker is back. That motherfucker is me. And I am back. Can we just print these parts? Okay, so what did we do? What's our steps here? Cat everything up. Get the load cell working. Get stepping the Uno from Python. That should be easy. Hold on, it's getting cold in here. I'm gonna close the door. Okay, alright. Now I'm actually back and I can print. Gotta warm up my hands. Okay, let's just print the parts and then we'll get working on the electronics. I don't know why I am like so weirded out about this. Pen mount, export, pen mount. What part am I building now? This part. Load cell mount. There you go. Okay. Okay. So that's it, right? That's all we need. Slice. I think we need to refresh this thing. See, why does this happen? This is such a bug. Retry. I don't know. I mean, it knows I have an AMS. Oh, you know what? There's parts on there right now. I can't print this. Hold on. I gotta go get them out from the because otherwise it's. Okay. Let me go get the parts off of the printer. Okay, so I got these prints, and I actually want to test this out. Let's test it out on the thin stuff, just to see. Oh yeah, I'm so glad I changed that geometry. This goes in and fits like a glove. The other one was just too small. Alright, well, not that I'm going to replace that or anything, but nice to know that it works. You know what? Here, I'm going to make a necklace. Your boy's getting a chain, bruh. Your boy's getting a chain, son. Check this out. Yo. Yo. What? What? My chain, son. Yeah. I don't know. I don't know what I'm doing. All right. So we're getting ready to print these parts. There we go. That's what I wanted. Green. I don't want green. I like the gray. Gray is my favorite color on these parts because it's subtle. It's not like it's trying to stand out. It's subtle. 30 minutes. Let's just do it. Okay, in that 30 minutes, let's get this thing working, I guess. So, we need a breadboard. Let's see, what is this? Oh, damn it. This is the most annoying thing. I guess what I really need, is... Hold on, let me... Annoyingly, this motherboard only has one Type-C cable, so... That's really freaking annoying, man. In any case, we just need to get... Okay, we just need to get this thing. Hold on, let me plug this in. Okay, let's push this back up to the wall. Oh my god. I can't believe I just did that. Luckily I didn't destroy anything, but that was close. Close call. Wait, can we get... Did it bing? I don't know. Hold on, let's just open up... What? Wait, but it's not COM4. Dude, my buddy just said I should apply to Formlabs. That's the chain talking, fam. That's the chain talking. Okay, wait, hold on. Damn it, this thing is gonna keep spamming. Let's hit disconnect. Okay, wait, hold on, but let me... Also, so... Okay. right, boys, boy. Yeah, homie got a chain, son. Yeah, homie got a chain. All right. So what are we doing now? I just spent the last freaking hour goofing off, doing nothing. Oh yeah. Okay. So let's get this load cell soldered up. Where did I put the thing? Okay. Here's the thing. So we just need to solder this together. And what am I gonna do? I feel like the worst thing you can do is put the wires in it. So I guess I'm going to... Oh, shit. I lost... Ugh, crap. Oh, here it is. Okay. Alright, so what we're going to do... Oh, wait. My mom is calling me. What the hell? Taking a selfie with my chain, bro. This is a dope chain, bro. I fucking love this chain. Yeah. Yeah. Check out this shit. Yeah, this is 24K, bro. This necklace, bro. This necklace cost me 25 G's. That's Rex on Rex, bro. Okay, whatever. Okay, so let's what are we doing now? I'm getting this thing to work, so I just gotta hop on the soldering table. How are we gonna do this? We're gonna like... I guess we'll... I could do it either like this. Let's do it like that. Okay, so where's the other one? Alright, so I'm just gonna hop on the soldering table and do this. Alright. Alright, so we're just gonna solder this thing in, and we're gonna start connecting it up. I guess, oh, but, hold on. You know what? Okay, wait, hold on. Okay, so why don't we just... Okay, wait, but that means that we need to know the... Ooh, caught it, bro. I've been catching stuff lately. I'm so good at it. Alright, I say we just put in the pins and then we solder to the pins. It's kind of stupid, but then at least I don't have to look at the pin out yet. Get this fucking chain off me. It's actually really uncomfortable. I can't stand having stuff around my neck. Okay, so... Yeah, let's just solder these in. We're going to solder them facing up. Alright, let's just do it. I don't know why I'm being so lame about it. Got my solder. Ay, ay, ay. Whatever. I gotta do another cleaning day. I hate cleaning, man. Alright. Homeboy? Homeboy? Homeboy freaky as hell, bro. Alright, I don't know why. Whenever I get a new IC, it always takes me forever to like start to use it. Okay. Okay, so let's just get this thing going. So wait, hold on. We need to figure out the pin out. Dude, is this thing still going? Delete. Kill it. Kill it. We need to... I don't know what we need to do, but we need to do something else. Open image in new tab. It just doesn't work. Dude, why did none of these work? Like, what is up with that? Why does this have so many... That is so ridiculous. That bothers the fuck out of me, honestly. Okay. So what we're going to do is we're going to just hardwire this thing. Oh, I guess you know what I didn't consider? Oh, wait. We have... I did this. This will work, bro. Alright, so we're going to finish this up. I knew there was going to be a use for this thing. The colors aren't right, which is annoying. Oh, but you know what? We could do the colors in the right way on this side. Wait, but should we do that? We could do that. Alright, so we'll have the colors the right way on this side. This cable's not technically long enough, but it'll be okay. Oh, this is perfect. Okay. Alright, we got a plan, man. So we're going to do that like that. And then this one, we're just going to solder this down. These cables are so freaking... It's actually ridiculous. The gauge of wire here is like 30. I don't know how you could use that gauge wire. Okay, one thing I sort of overlooked. Okay, red goes to E+. Black E-, white A. Okay, so let's just solder it down. And then we'll see if we'll be able to see if it works. So for right now I'm just going to use little jumpers. We're just going to use normal breadboard wires, but homeboy. Whatever. Oh. Okay. Red goes to E plus. Then it's black to E minus. Then it's white to A minus. Black to E minus. Fuck. Let's get some. Alright, homies. We got it. So we did it. So now we just gotta freaking crimp this stupid ass you know what? We're not gonna crimp it. We're not gonna crimp it yet. We're gonna crimp it later. And that's for when we really integrate this thing. Might even need to make it longer, which is gonna be a pain in the butt. Also, did this thing ever actually connect? Oh yeah, it did. It probably played on stream and didn't play through my speakers. Okay, so let's see here. Now we need to get some these had a storage place on the ground for some reason. All right, so we need female to male. Buy these in packs of 1,000, bro. Okay, so we need ground. So we need a... Whatever, let's just tear them out. Who cares? These things are cheap. I don't know why. I treat everything like it's so important. Alright, we need a red one. We need a black one. We can use an orange and a yellow. Oh, wait, that's too close together. A white and an orange. Or a white and a gray. Or... Oh, we got purple. Alright, purple and orange. Perfect. Alright, we got the same as the ones in the picture. Alright, let's hook this thing up. Alright, so we got... So ground is obviously black, so let's just get that down. Okay, we should be able to power this with 3 volts. So we got this. VCC. Okay, now purple goes to pin... Let's see, can we look up? I want to make a clip of this, just in case. Let's see. There's probably already a video of this. They both look pretty good. Let's see how this one is. This one seems kind of... Oh, it's in Hindi?
Yeah, hi. We are from SVS Embedded. The project title name is Raspberry Pi Pico Weighing Scale with Load Cell and HX711 module. So here we are using an 5, 10, 11, 12, 13, 14, 15.
What kind of off-brand Pico is that, bro?
Welcome to PicoGenius.com, where science, electronics, and microcontrollers come together. Today I'm going to show you how to build a weight scale using a load cell. And in addition, we're going to look at the HX711 load cell amplifier, and we're going to interface this to the Raspberry Pico Pi microcontroller. I originally created this video as a one-part video, but because of the length, I broke it into 2 parts. Part 1 will give you a flavor for how to build a weight scale, components that you need, and some of the software that's required to make a weight scale work. If this looks like something that you would be interested in building, part 2 will give you additional information, even when there's a full load on the book. It also has selectable gain of 32, 64, or 120 signals to the bridge, and the B plus pins, E and SCK pins. This is a block diagram of the weight scale interface running fine. Power from the USB powers the Pico Pi, the HX711, and excites the bridge circuit in the load cell. 5 volts on the Pico Pi, pin 4.
Wait, is there a... I thought there wasn't. Oh, V bus is 5 volts. All right, so if we need that, we can also do that just straight from the because the current, right? Okay, yeah, because USB can't supply the current, but it can supply the voltage, and the current draw of this chip is like in the milliamps, so it's not like a big deal.
40 powers the VCC on the 8.
All right, and then we should just use... What is this? What's up with the logic analyzer? I don't know why they need a logic analyzer. What is that for? All right, so let's just hook it up to 18 and 19. So hold on. Clock is on 18. Okay. So where are our things? So what was the color of this thing? So clock was yellow, and data is purple. Okay. So purple goes to 19, but what? How many is that from the top? I wish the solder mask on the Pico on the top had the freaking thing. It's so data is 19. 19 is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And where's the last one? Here's the last one. Just need to get this thing working. It's not. We're not doing anything huge. All right, so it should be all hooked up except for voltage. We just need a little. Let's see. Should we do the 3 volts or the 5 volts? Let's try 3 volts, but I don't really care. 1, 2, 3, 4, 5. Fuck. Get in there, you bastard! Ugh, it's too short. Let's try a different one. There, that looks like it might work. Perfect. Okay. So it should be working right now, right? We just need to read off of it. We should be able to just copy this code and then put a script at the end, right? Because if you run this, you define it. What's the test? The test uses... What's the difference between SPI? It's like a register or something? That's awesome, bro. I love that people support this and they don't even write the library. This is just a random guy and he's like providing support. That's the amazing thing about open source, dude. Okay, so wait, I want to copy the README and get some more. You know, it's so funny, these libraries, they just assume that you know how to install it and use it. Directly bitbangs GPIO. Alright, so let's try that. Can we just try that? Okay, let's just try that. So I'm going to copy the whole library. So here's what we're going to do. Wait, we're going to unplug the... Okay, let's try to go back to this. Beautiful. Okay. So what we want to do is we want to run a big ass piece of code. Here's what I want to do. I want to close this. Wait, what? How did that even happen? Wait, how do I know which port I'm on? Okay, wait, hold on. Ampy-P com3 LF. I feel like this is... Whoa. What? How did that even get into my... That was weird. Okay, wait, hold on. What am I trying to do here? What is mode? I don't believe this is a thing. The fuck, dude? No, it won't. The hell are you talking about? Maybe it's COM 6. It's probably COM 6. Lol. Wait, but is it because of... It could be because, like, it doesn't actually close the fucking thing. Yeah, see, disconnect. Closing port. There we go. There we go. What? I hate when they do that to me. Okay, so this is what we want to do. We're going to do ampy -p com6 rm vl. What is it called? VL53L0. Is it X? Is there an X at the end? Yeah. Okay. Okay, now we want to get that code and put it on there. So this thing, we want to take the GPIO one. We just want to copy it. Call it. Okay. Ampy -p com6 put hx7.py. And then is that all we have to do? Okay, now if I connect, it's going to open up the... Okay, import hx711. Wow. That's cool. Okay, wait, so now how do we use it? I have the what is it? The data pin of the chip on Pico pin, what is it, 19? Pretty sure it's 19, right? I should be able to just run this, right? Oh, fuck yeah. Wait, is it? Yeah, I am bending it in the right way. Why are the readings negative? It seems pretty accurate though. All right, so it works. I mean, that's pretty cool. I just don't know why it's negative.
One more thing.
Okay, so it's negative. Why is it negative? Oh, tear? Oh, that's cool. It didn't zero it at all. Okay, so now what do we need to do is we need to okay, wait, hold on. So wait, let's just if we do hx.read. What? All right. So that's what all we have to do. So okay, wait. So let's say let's write the code. Load cell map dot py dot oi dot oi dot oi. Da oi, da oi, da oi. Okay, so basically what we need to do. Alright, we can move all this. Okay, so what does this thing need to do? Oh, my prints are probably done. We can probably go mount this thing now. Dot oi! Dot oi! Okay, so we need to do this. Open up COM 4 and 6. Home. Okay, so then home the machine. Then create grid of points from sure, something like that. And then yeah, for each point in the grid, move to the point, read the load cell, do that. That's basically it. Oh wait, initialize init the hx with coding has never been easier. I'm gonna go get my parts, I think. My parts are surely done. Or is the baud the same? I think the baud is the same. Wait, what? Wait, hold on. Weird. You don't need a feed if it's a rapid, right? I don't know. Maybe it does take a rapid. I don't know. Send the G. Alright, so it makes the G code. It says what it's gonna do. It does that. It sleeps for a second. That's way too long. Read load cell value. Wait, but hold on. But this is Wait, what? No, I don't think that works. I don't think that works. Because I think you need to do this whole UART thing, which is a total pain in the butt. Oh, I just got the print success notification. Okay, so what do we do then? I don't think that works. I'm pretty sure that doesn't work. So instead, why don't we just try this? I feel like that this is gonna work. Wait, hold on. What did this say? Okay, let's try this. We're gonna try this. So I'm gonna say, let's close this. Is this gonna close this tab? No. All right, so we're gonna do ampy -p com6 put hx711 or read. Do we have enough space for that? I guess we do. So now I can do ampy -p com6 run read hx711.py. Oh, interesting. So, okay, wait, but so it just starts printing. And run and print its output. I don't know if, like, if it's printing to the terminal, can you also connect to the the COM port. Yes, it still works streaming since ampy run executes the script directly on the board and prints it output to the terminal, which prints the readings. Will listens for new lines on COM 6. Is that true? I guess you can read multiple. Okay, so we have this. So let's just try this. All right, so read from com.py. I don't know. So this is just normal Python. So I should just run this. Python run that. So okay, so first off, let's do this. Let's open up a new terminal and do Python read from com. See, but that's what I'm saying, bro. Is because this COM port is open. What is it saying? Yeah, I close ampy. Oh, wait, is that true? Is there a reset? What does reset do? Wait, don't you call it like main or something? Isn't there like a... Do you have to do that? Okay, so if it's running... Okay, wait, hold on. I found this. Yeah, I don't think you need to put the boot cell. Let's see. I didn't read all this, but... I don't know how to get out of that, but I don't really care at this point. But if I have print calls in main.py, we should do a simpler test than use the HX. We should just have a, like, it's just a counter that prints. How can I read the... Okay, so let's try this. So what we're going to do is print, or I guess we're going to call it main.py. And we're basically say, there we go. Okay, so what we want to do is we want to do ampy.p com6 put main.py. Oh, because it's still fucking open here. What? Oh, wait. What? There we go. Okay, so now if I unplug this and plug it back in. God damn it. Who's stretching out all the plugs? Plug! Plug. All right, wait, hold on. Okay, so now it should be running. So now, let's fucking do this. Yeah, I think it's basically this. Ugh, I wish double clicking would fucking rename it. So stupid. Okay, perfect. All right, so we do have it. We do in fact have it. All right. Good stuff. Okay, so now how do I... Yeah, what if I need to stop? Let's see. Does that work? Dude, Ampy is sick. I love Ampy. It's like so much easier. The fact that the freaking Pico has a file system is so nice. Okay, so read HX should be all we need. So it's going to be writing really fast. Okay, great. All right. So now, okay, so we're freaking ready. So we can delete this. We're going to rename this to main.py. This is going to be main.py. Okay, so now what is the whole thing? Load cell map. Load cell map. What is it called? What was the whole script now? Okay, so now... What? Wait, what just happened? Thank God. That's the type of thing that would leak your email in... Oh, it doesn't even show up. Oh, that's interesting. That's cool. Okay, so I can successfully read from the main.py using the serial port, and we don't have the problem where it's Ampy is like taking control of it or whatever. Anyways, so that's great. The next thing we need to do is, can you show me the script again of where I, generate the grid of points and I do all the stuff where I open both COM ports and I send the G code, I home it, I do all of that stuff. Because we're ready for that now. Alright, we're actually getting kind of close here. So I want to test it before I actually... I love these fucking emojis, dude. How the hell did it... Who told you to start using emojis? Alright, so, yeah, map, load cell map.py. Okay, so this is going to be... Xmax is going to be 400. Ymax is going to be 240. Okay, so wait, so hold on. This what? Oh. Okay. So we're going to say this. We're going to call this main. Okay, so we should be able to just unplug it. And plug it back in. And then we should be able to do read from COM, Python read from COM. Is this good? Pico says. Okay. Should be able to, this is what we wanted. Okay, we can delete this. Alright, so we should be able to just run this right now. Oh, because... Let's see, did this take control? No. I don't think it did. Okay. Okay, homing is not working. That's pretty sweet though, actually. But it's gonna do it in a suboptimal way, right? We need it, we want it to zigzag. We don't care which order that it's written in. But yeah, why isn't it I wonder if does it catch an error? It doesn't catch it if there's an error. I wonder if it flushes if I kill it. This is gonna take forever, bro. Alright, so it did get the readings. I mean, that's awesome. So this is exactly what we want, except for the fact that... Okay, wait, hold on. Let's do this. Okay, so why did that work? Let's see. That all seems good. Home the machine. Send GRBL command. I think, okay, wait, hold on. Let's just go to, I forget what it's called. I think it was in here. And in here I had a whole bunch of shit. Oh yeah, like this penis.py stuff. Monitor. Readline.decode. You know, it's probably missing the new line. No, it has the new line. Sure.write.encode UTF-8. Let's just try to do that. Try to run it again. Maybe we gotta close the let's see if this no, I don't, it's obviously gonna error. So let's close this. Right. Why didn't it work? Let's go back to this thing. I like how fast that is. I wonder if I can make it faster. Okay, so the machine's moving here. Okay, I don't know why. But isn't there a 5-second sleep after the thing? Oh, well, let's do this. Where is it open at? What's up with the emojis? I don't really get it. Oh, wait, is it gonna wait all the way? Wait, hold on. Oh, yeah, I forgot about this. When you start it up, you gotta, like, wait a while. Why isn't it? Can we do the freaking UTF-8 thing too? You know, oh, you know what? No, ugh, bro, I'm so stupid. Hold on. Oh, and it's just gonna keep doing that? Alright, this should work. All right, we're basically in business. What's up, Riley? You're at a good point in the thing. So right now what's happening is I'm ready to make a grid of points. Wait, what? Wait, X and Y are mixed up. Oh wait, this got changed. Yeah, let me go get the camera. I gotta go get it. Give me 1 second. I'm gonna go get the tripod. tripod and camera. Okay. Riley's still here? Okay. Give me 1 second. Got the camera. Where is the here we go. Okay. All right. So, let me explain what's going on here. No, I actually borrowed this camera. This is not my camera. I wish I had a better mic. Okay, Riley, I'm back. Alright, sorry that took me so long. I had to get my printed parts. Sorry, that was my bad. I had to get my printed parts here, and we are going to mount them now. I gotta get my bag of shame. Yeah, I'm here. Do you see me? DB rear end? What the hell does that mean? Oh, yeah, the dick butt rear end, yeah. Okay. So let's see, this part's not going to go far enough, so we need longer M3s. Let's see, do we have any longer 3s? This. Still not long enough. Okay. Let me calculate what we need. I think we need 20s. Okay, so we have this. Now, let's just, okay, so, alright, so we have more work to do. But basically, this is going to be like this. And we need the M4s. Okay, so let's, so these are back in the shame. These we don't need anymore. Actually, wait, we need them for this. Okay. So maybe we'll just do that right now. But we don't need, this is 10 and this is like 12. So 20s are actually good for this. Oh wait, no wait, hold on. I'm mistaken. These are all M4s. And these are all M3s. Okay. Need 2 more. So first off, oh wait, this is gonna be too long for this. Because we only have, okay, so wait, we only need 2 of these. Okay, so let's do it like this. Will there be a y-axis on the current tinycnc? There is a y-axis. This is y. You mean z, and yes, there will be a z-axis. I need to redesign it. Okay, so that's that. So now we need like now we need like a 16. These 5s? No, these are 4s. Okay, these are the ones that I want. Why isn't that working like I want it to? Why is it... Is it hitting the bottom? Why is there so much play there? The screen went to noise? Oh, to no noise. This is not working like I wanted it to. Let's see if I can get an M4 threaded insert in there. Nickelodeon Resignate. No, I haven't. Let's see if I can get a threaded insert in there. Maybe it's going to be easier to get it. I don't know. Something is weird. Or let's just see if I can do it right here. They are hella big, but we're gonna try anyway. Wait, hold on. Oh no. How does the models hold their grip to the Sharpie? There's a thumb screw here. I can't get it to thread on there. Whatever, let's give up on that. Let's just see if I can get one of them. Do you see that though? Yeah, what's up, Riley? Dude, you can't do that shit to me. Come on, man. That's not right. I think I'm going to redesign this part really quickly. Okay, so here's what we're doing, Ole. So I got this cool thing called a load cell. And we have, I just had GPT write this code. Where basically, okay, so I have 2 microcontrollers now. I got the GRBL controller. And then I have this Raspberry Pi Pico that gets hooked up to this chip. It's basically it's a 24-bit analog digital converter with an amplifier built into it, and then this is a load cell. And so if I press on this or I pull up on this, it creates a voltage that can be amplified. So here, let me give you a demonstration. Okay, so this goes data, clock, voltage, and ground. Alright, so that's all hooked up. So I do need, yes, but we are not going to need this for the final thing. This is only to get a sense for how flat the board is. So basically, I'm going to put the pen in. Let's get a, wait, hold on. Let me clean up a little bit. So this is only temporary. It's just because I need to... Okay, so hold on. So let's see how this is gonna get. We don't want to use this pen. We want to use like a regular Sharpie. Okay, so this is gonna go like this. Let's get a thumb screw. This should be good. No, that's an M6. Oh shit, I think I made that the wrong size. These are all M6s. Okay, I think that this will work. Okay, so we're gonna need to reprint these parts. But basically the idea is you get this down tight, and then I'm going to sweep across, and I'm going to measure how much. See you, Riley. How much force is applied? Okay, but I'm realizing now, before we do that, we are going to need to hop into CAD really quickly. Anyway, so the point of all that is that we basically just, I need to have a better sense of like, honestly, I just think it's cool. I think it's going to be a useful and cool thing to do. Okay, so let's just hop into CAD and fix it. Okay, so this design, first off, this we make that 6. That should have also changed. Great. So this part works fine. I think this part is nice and strong on there. The problem is, so wait, let's export that again. Is this part is terrible. So let me think about how we want to do this. I'm also going to get a okay, so how do I want to do this? I could have a real deep counterbore there. Okay, because basically the problem that I think is happening is the helices are not lined up. So if this bottom one is threaded, it's not really worth anything. So what we want is we want to have it, we want to make a pocket. We're going to make a pocket. I think we should be able to make a pocket that starts at sort of below this point so that we... Okay, so let's go edit this. We're going to draw the outline for this. This is like 12.7. We can make it like 13. And then I forget what this here is. Okay, so let's just switch to this. So I did make this 3.6. We can leave that. It's kind of vestigial, but here's what we're going to do. So first off, we're going to draw a line from like here to like there. And what we're planning on doing... So hold on, but the problem with this is you kind of need like 2 at least. So maybe we won't, maybe we'll do it like this. So if we go like this, then we go like, and then we mirror it, and we have this, well, I guess, wait, hold on. If I go like this, how do I make sure it's mid-pointed? Okay, so this is okay. So that's how wide it needs to be. So we need to have then like a rectangle. Okay, and then this, just make this like 3. That's quite far. Is that how far? We want it to actually bottom out at the right point. So what actually is this number? I think it's oh wait, here's what I'm gonna do. So I'm gonna go to the load cell. We have all of it here, so we need to actually go to this sketch. We're gonna take this. So this is going to be whole center to edge. So we're gonna do that, but unfortunately this is not a program made by programmers. So okay, wait, hold on. So it's first off LC whole sent to edge to short edge. I don't know. And we can put it like this, and then that should just calculate out. So then we can make a version here, and then we can say LC. Oh wait, then we need to actually do this. Okay, and that's all calculated, and that's an expression. And you know, it's so stupid is that you can't even see what this expression is without going all the way back here. I've said this so many times in the past because I've been doing so much CAD recently, just trying to get this project to the finish line. But I swear, Onshape is like my favorite CAD. I've really tried 2, but I've tried 3. I've tried 4 in quotes. I haven't tried SolidWorks. That's the big one that I haven't tried. But I still would rate this program a 3 out of 10 because it's just so stupid so much of the time. All right, so what's next is so now that we've done that, oh yeah, I can just hop back. Yeah, I don't think so, man. Let's see. Yeah, I don't know. I think it's just that it's kind of like, dude, it's kind of like the PCB designing software. Dude, Easy EDA, the PCB. Yeah, but like, okay, here, I'll go through it. This one's a total donkey. I know that like, this one. I don't know. I'm quite sure. I'm pretty confident that because I'm thinking like a programmer where it's like, okay, let me show you a crazy example. This is what's so crazy. I draw a circle here, and then I want to put in some variables, LC, whatever, times 2, you know, plus 5 millimeters. Okay, this expression, you can hover over it, but if you want to edit it, they give you 15 freaking characters to put this little box. Why can't I put expressions in here? It's just like, so stupid. I don't really care. But we do want to delete that sketch. Okay. It's not like it's that bad, but it's just kind of annoying. Oh, but we need to do this. And this whole updating the variable studios is really annoying me. So we're in Y-care right now. This needs to be that LC edge thing. So that's where it's backing out. So we kind of want... So, okay, so I'm not going to do that then. I'm just going to build it here. So in this sketch, we're going to do this. Oh, let me make sure that my chat is working. Alright. So what I'm going to do is we're just going to do like a line here and a line here. And we're going to mirror that, but we're going to make this, let's make it like 5. I want to make it chonky. And then this. See, that's a problem. That's a huge problem. Okay, so wait, actually, how the hell am I gonna do this? I don't have enough room, man. Okay, I think I know what I'm gonna do. The initial extrusion. Okay, wait, hold on. I got an idea. Oh, wait. No, what I'm talking about is this. Oh, this is all just one thing. If we make this 10. I really wanted to use that hole tool. I wonder if I can do it here. Hole. You can't just select. Oh, you can. Hold on. Oh, but you still can't print. You still can't print on top of it. So even if you make it counterboard. So that means that we need to actually move this out more. We need to move this to be over the edge, which is fine. All right, so we're going to revert it back to this, because that's definitely plenty. But this sketch, we want to draw like this, and we'll just make it 10 more out. And then when we do this extrusion, we're also going to just select this. Okay, then when we draw this sketch, it's not to here. Wait, can we undo that? It's how did we get 15? Is there a 15? No, okay. Okay, now we have a ton of room. So now we can finally... What is that? What is that? Oh, that's goofy as fuck. Oh, because it picked the wrong one? Okay, that's okay. Alright, so let's get the construction rectangle. Oops, what just happened? Okay, let's make this LC width plus 0.25 millimeters. That seems like enough clearance. Honestly, I've been getting pockets with crazy good okay, so now we want to get this point and this to be mid-pointed. And then we want this to be... We want this to be LC sent to edge. Okay, now we basically want another rectangle that's like why is that doing that? Oh, it's because it thinks I'm holding it down. That's weird. Alright, we want to do the same thing, and then we can just do this. I think that's already, yeah. Okay, and now we should be able to just, actually, we want to make this not construction. Okay, and then this is going to be LC width. I want it to be kind of snug, but I'm still going to add. Okay, and now we just need to sketch on here, normal, G. Okay, now we want to sketch on here. And we're just going to use these. See, but that's what's crazy. That's what's crazy. Okay, another ridiculous thing. Okay. Let's go to on shape bad. Even though my default units are metric, the whole feature defaults to imperial. Why? Why? So you're gonna make me click that every freaking time? I don't even understand what this is saying. This feature is... So, okay, let me just use it for the correct time. So, this is going to be M3 socket head hole. Okay, then this is going to be M3 socket head depth. Then this is going to be... See, and can you do this through? Ugh, holes are so dumb. And there's no way... Ugh. I don't know, man. This seems really stupid. So what is this? Drill size? What is it? Okay, if I set the drill size to 5, and then I set this to M3 hole. Oh, I don't even understand why they did this. It's so bad. So if I do this, I don't know. Maybe it's not the worst, but I like that it has the GDT call out. That's nice. This thing is crazy, though. It should be... What's nice is that by forcing you to have the depth, they know the depth. But also, there should be a feature to do up to face and up to next in here. Alright, let me just keep my notes. The depth on the whole feature should allow for up to next, up to face or blind. Like in extrude. Alright. So am I going to use this? But this isn't even right. Okay, I don't need this. I don't need this. We're going to delete this. We're going to sketch this. And we are just going to remove... Oops. Okay, so then you're going to put the thing in there. These are not going to be... Oh, wait, what's the diameter on these? Oh, we used them? Oh, that's not right. Okay, so wait. What we need to do is come here. Q, C. Oops. C. Okay, so this is going to be the part. The crazy thing is this is kind of a annoying to print part. Do we have enough room here? 3 should be enough for an M3. Okay, so alright, let's export and print it again. This should be a lot better now. I didn't increase the thickness of this thing, right? Okay, but we should have a pretty beefy stand. It doesn't actually go back that far. I mean, we can make it go back as far as we want, but it's good. I think that this will be fine. Oops. Wow, I'm surprised. No support. Okay. Ugh, but then I gotta tap them all again. It's kind of annoying. Kind of annoying. I should just be working on the Z-axis at this point. Oh, but we're so close to the height map. It's gonna be sweet, man. The height map's gonna be awesome. Why don't we try... Well, okay, wait, hold on. So what we need to do now is, I guess, crimp these wires. And what we're going to do is we're going to crimp them in the order that we need them to be in. And then the idea is, okay, this thing... Okay, so this thing is just gonna sit... Oh, you know what we should do, actually? Should I put this in a little spot, maybe? That'd be kind of cool. Let's see, what's the diameter of that hole? The PCB I don't think came with drawings. Oh yeah, it did, kind of. This thing is pretty well documented. So why don't we just add... Let's see. Why don't we just design a little place for it? So all we want to do is on here... We're just going to put a little mount for this thing. It's going to sit like that. Okay, so let me just... And this is what I do, because I'm crazy. 20 by 33. Okay. Okay. Wait, why we don't really need the PCB in there, but it's okay. This is going to be the mount. This is going to be the mount hole edge to all right, so we have all of the. So this is like a fully defining thing, basically. Okay, so let's get this thing started. .3 and 3. Okay, so to long edge is 1.3. Wait, we don't really need that, but might as well. 12 plus 2. Oh, wait, hold on. We need the diameter. 3. .33. Okay, that should be enough. Mount hole diameter, short edge, and it's in the center. So that's all we need. Okay, so now we just need to make a version. Okay. All right, so let's just do this. This is going to be easy. Rectangle. And then we can mirror it. Okay. Wait, this is not right. That's sort of as much as I'm willing to do. But we got all the geometry, right? The major geometry. Okay, so what we're going to do here. I guess threaded inserts. That kind of stinks. I wish there was a better way to attach stuff. But we do need a place for it. I concur. So what we're going to do is we're just going to put 2 holes here. Doesn't really matter where we put them. Oh, hold on, let's do So wait, hold on. We got to get this right because the center distance. Hold on, let me just make sure. So here's what I can do. Is I can go to this, this, this. And make sure that we get 14.4. So 22 minus 2.6 minus 3. Oh wait, no. So okay, hold on. Wait, what? It's gonna be, yeah, 2.6 minus 3. How is this 14.4? Am I crazy? 20? Okay, wait, we're trying to find the distance between here and here. So we're gonna do, so we get 20, and we're gonna subtract out 2.6. Then we're gonna subtract out 3. Oh wait, why did I do 22? Yeah, that's right. Okay, so it's gonna be, jeez. This minus 2 times long edge. Yeah, it is 14.4 to long edge. Then minus the diameter. PCB diam. Okay, there we go. So now we gotta make a version. And then this is all good. And we just want to update this. And then let's go back to this. Okay, so we're in this sketch. These are equal. So are we going to do a threaded insert here? Why don't we just tap it? Let's just do them tapped. M3 tap. PCB sent PCB. I think it hasn't updated yet. So let's do this. Refresh. Oh, because did I not call it? Oh, I'm stupid. Okay, and then we could just put it in the middle, I guess. So, I forget the right way to do this, but if you do this, I think the best way to do this is just midpoint it. But then is this stuck there? Yeah, that's not what you want. First off, okay, so wait, how do I think the only way to do this is like this. I guess you want it as low as possible. So we want this to be, let's make it like long edge plus like 2 millimeters. Okay, so then if we do this, we just go through it. I concur, indubitably. Alright, so now, I'm pretty sure that's all we need. We're just gonna extrude, remove, up to next. We're just gonna tap all the way through that thing. Oh, okay, so I did not think about that. Okay, so we actually don't want it in the midpoint. We want this to be, oh wait, you know what I did wrong? This to long edge plus 2 millimeters. Okay, so now we get a little bit more room there. Okay, and then wait, that's too long edge. This needs to be too short edge. It's okay. And this is going to be to the long edge. And then if we do this, we should be fine now. Oh yeah, look how small of a... Okay, so then this is exactly what I want. Okay, so now if we go into the assembly... Okay, cool. Everything stayed the same. Now we just need to insert HPCB. And actually, can we freaking... I wish they just had PCB color. What is the hex code? PCB green. Everyone wants to know. I did, but I reprinted it. Oh, yo, check it out, Yoel. Your boy got a chain. I got a chain, bruh. Anyways, pure green. All right, let's do that. I didn't install it because it's just such a pain, but it's a lot better with the clearance, man. It's a lot better. Oh yeah, that looks good. That looks like a PCB. Let's go back. Straight thuggin'. Oops, I did it wrong. We need this one to go to there. Oh, not to there, to there. Okay. Wait, how did I still get it wrong? How am I so bad at this? God damn it. Wait, hold on. If I'm like this, and this goes to there. Okay, I'm handicapped, bro. But just keep guessing. Okay, there we go. Alright. So that's what that's about. So then we're going to have this. And then the cables are going to run along here. And, alright, so it's time to print this. And, I know. Well, the thing is, I was doing the same thing over and over again with no expected, well, you know, with the expectation of it changing. All right, so there is a load cell. Yes, so what we're doing is we're doing like a height map type of vibe. So honestly, this whole thing is like sort of pea-brained because like if I'm gonna measure the height, then I can't rely on the board itself to be flat to measure the flatness. But if you just ignore logic, this thing is gonna be cool. So yes, basically we have a load cell here, and then we have the pen mounted on like this. We have a PCB for the amplifier, and it's going to go to a second microcontroller, and that second microcontroller is going to read the values. And I've already written all the code for this. So all we really need to do is freaking crimp cables. This thing came in handy, man. And it's actually quite long. I forget what this was for. What was this for? This was for the this was for that I squared C fucking thing. This is for that time of flight. So we're still back on my bullshit time of flight nonsense. But yeah, so that's basically the plan here. And then we can just I just want to make a pretty picture, honestly. Like, you know, I feel like there's so many YouTube channels make these beautiful diagrams where they collect data and they have a methodology and all of this crud, and I never do that. So I wanted to at least be able to make something kind of nice. I honestly have no idea what to expect. The thing is, I don't really have any way of I don't know how to translate the actual, this load cell, it measures its own strain, right? But I don't think that you can take its readings and then use that to infer a strain. So I'm not sure really what I'm expecting to get out of this. But I was seeing, like, the thing is, honestly, most of that was based on the cantilever. So then I have completely redesigned this. It should be pretty flat. This whole thing is basically because I really want to be able to use these pens, which have the smallest little tip on them. But they're so good. They write so well. So anyways, I printed that. Oh, here, wait, hold on. Let me just delete this. If you have the ability to adjust the pen, how much pressure you're applying, that's I don't know what that means. Like, that's getting closer. Oh, that's getting to how a person draws. Yeah. So the thing is, okay, this is the problem though. With normal G code, or at least with GRBL, as far as I can tell, there is actually no way to take the reading of this and do a closed loop type of feedback where instead of going to an absolute Z, you go to, so I'd have to build like a layer on top of GRBL where I basically like do this annoying two-stage procedure, which honestly would be pretty cool because it would be like a demonstration of a real closed loop system. But anyways, what I would do, but it would just be so slow. It'd be so slow because basically any time, and the only way to get the proper value with calibration. Well, you know what I could do? I could sample points. But GRBL would still have to know that value. But here's what I was thinking. So I could, before I put down the paper, I sample, 25 points or whatever, and then I modify the G code generation in a way that that corresponds to that. Because I think that's what 3D printers do, is they basically, when they sample those points, they then use that to inform the G code process. That's at least my understanding. how would the second Arduino know when it needs to be up or down? Anyways, I need to go soon because I'm starving. But I do want to know, because the thing is, if it's going to raise up and down, it needs to know when it needs to apply the pressure. A pulse width trigger. I mean, I have spare pins, so that's not really an issue. I guess I can. But I guess I would probably have to modify the... I'd have to modify the G-code generation to send out I don't know how I'm gonna do that. I mean, I see what you're saying. I think I just don't. There's some unknowns on how that would work. I wonder why the load cell has this weird geometry in the center of it. I want to see someone cut one of these in half. It probably... That's actually you're really smart, because that is exactly how the PWM for the... Oh, you know what? Hold on. That's where it's going to flex. Right. Yeah, because you need it to flex a lot. You can't just... If it was solid aluminum, yeah, it would be crazy. Yeah, I mean, that's exactly right. Is that the way that the GRBL plotter does it is but it sends out a pulse width on one of the end stop pins. How it senses the limit switch. That's exactly right. So if I sent that signal... If I sent, let's see. So Arduino 1 that's running GRBL says pen down. But then it needs to wait for confirmation somehow, right? So I would need 2 pins or something like that. But the thing is, I don't, because you would basically, because you can't just say pen down and assume that it happens instantly. Oh, how does it do waits? That's actually an interesting point. I don't know how it does pauses. A G4. I wonder what the generation does on this side. Let's see. Okay, if I do dick butt. Oh yeah, see how it does? It just does G4s. So, okay, I mean, I guess what I would do So here's what I would do: is I would basically figure out how long it takes to do that process where it does the calculation and it gets to a certain pressure amount. And then I would sample that a bunch of times from a bunch of different places. And that would be really cool, dude. That would be really freaking cool. If I could really precisely control the pen pressure. I've wanted to do that for a long time, but now I actually see how I could do it. That's cool. That's a good idea. Okay, I gotta go make dinner. I'll see you soon. I might hop back on later. I don't know what time zone you're in, but I might hop back on later when the prints are done, just to try to get a very crude picture down. Because I've been slacking on my cadence of I do a live stream and then I do a short, because that's a formula that I've seen low-key work for me. Honestly, though, I need some bangers. That's why Ole's been on me for, like, weeks now about how we just got to get this thing done. And I've just been, like... I'm so bad about just getting a project done. Yeah, I saw that inductive thing. I wonder how they do it. But they probably... Actually, what microcontrollers are in standard 3D printers? That's what I want to know. Yeah, I've seen that. But the thing is, can you do that? Because the live streams in short orientation, it'll show up in people's feeds. Like when you're swiping on shorts, it'll show up there. But these streams don't show up there, I don't think. Yeah, that's a super good point, because that's like a huge vector. They're all on ESP32. What NC controller do they use? Because I was just reading about Fluid NC. I was just reading about this. This would be fun. Do they have good They use ESP32. That's fucking awesome. Do they have boards for this though? Like, what's an example? Like, if I want to use like standard, whatever they're called, A4988s. Do they have like a reference implementation of some standard gantries? Yeah. It seems like the modern... Dude, should I have been using a freaking Arduino? The thing is, I guess it... Let's see. Fluid NC PCB. There we go. Look at that. That's a 6-axis control system, bro. That's fucking cool. Look at this thing, dude. Oh my god, this is really cool. It's just easy EDA and you just order the PCB. That's so cool, man. Look at this. What are all these? These are relays? What is that? I can't even tell what that is. Does the ESP32 have enough pins? Not that I need 6-axis, but that is really cool, man. Dude, Fluid NC is the shit. Yeah, if I were to build a router, like a real router with a spindle, I would probably... Because the thing is, I don't know, what is the advantage of having a higher clock speed? Because the ESP is like 210 megahertz, and the Arduino is like 16 megahertz. Any of them are set up for a spindle, so likely... But what were those things? Like, what were these? These don't look like relays. Dude, this open image in a new tab is just broken. Firefox is such a garbage browser. Can we just look at the Oh, I guess this is all I needed. I don't know why I do this where I ask all these questions that are so obvious. Okay, so this is the ESP32. Is it? Is this the ESP32? Yeah. Does it have regulators on board? What is this? What is this chip? I don't know what that is. Oh, you can have a voltage selection? That's cool. Dude, these boards are so much better than the speed in all areas. Let's see, wait, hold on. So what are these? What's I2S? I don't even know what that means. I also never understood what the point of these decoupling capacitors is. Everyone says you gotta add this, and I never understood this. On their board, they have a voltage regulator, so you can put it... That's great, because the thing about... Because I had to hack in my own thing for the voltage regulator. I wonder if you can control a servo. Dude, because that would be really nice. If I could do... Oh, Fluid NC is wireless. Dude, that's so nice. I don't know why I didn't just buy one of these. Next time, I'm totally going with this. Okay, so these are all the steppers. These are the 6 steppers. What are the 6 axes? I've never even seen a 6-axis CNC. I've only seen 5-axis. When do you need 6 axes? Oh, it's serial. Mosey. Isn't that for a camera? Oh, these are I/O modules. Oh my gosh, it's got a micro SD thing. Dude, this board is really cool. This thing is really, really cool. What are those drivers? I wish the open image in a new tab worked. Because those are the good drivers, I think. Those are like the, what are they called? I had a strip of them, but I couldn't use them because the pinout was slightly different. It would be fun to design my own. I could easily design my own. Honestly, though, it sounds fun. Oh, yeah, this is what I was talking about. TMC 2209. What do you mean not for sale? If it's open source, it's for sale. That's a tiny board, man. This is cool. I love these I love these barrel connectors. I wish I had gone with a barrel connector. Wow, Fluid NC is really cool, man. A lot of people just design their board, and if it's a good idea, they sell it. Yeah. Well, that's what's so cool. I'm so down for this open source hardware, you know, wave. Because it's so easy to build stuff when everyone's already done all the heavy lifting. It's like finally the ideas from open source software are reaching hardware where people aren't just constantly reinventing the wheel. Because let's be honest, that's exactly what happened for 20, 30 years. Oh yeah, I've heard of these guys. They do a ton of the the parallel port one. I bought a PCB for exactly. You know what I want to know about is like how I know it depends on how much current you can supply and all this. Because I wonder, where was that drawing? Where's the power? V-mote. Because does it give you a bomb? If I go back, does it give me a bomb? There's the thing. Here's the bomb. So I wanted to know what that, where were the ICs? What was it called? U4? Yeah, what is this? Oh, it's like an adjustable buck. Oh, it's a regulator. Adjustable regulator. Yeah, that's what I thought. Okay. That makes sense. Yeah. I know they have a rating, but like, I guess what I want to know is like for real CNCs, like plasmas and all that, you see those beefy drivers, those drivers that are like that big, like they're really big, and they can drive like 7 amps or whatever. But it's like, how much current do you really need? Like I don't know. Like, could I drive a CNC router off of this or a plasma cutter? Probably not. Like, if I could drive some NEMA 23s, some real heavy-duty motors, then it's like, this board is perfect. It's so compact. So cool. All right, I'm gonna go eat. See ya, y'all. Yeah. So what did I do today? I basically didn't do anything. A small CNC off of that up to 23. What was the current draw on that? Yeah, it's probably like, let's see. Oh, McMaster sells motors? Oh, you know what? Does Fluid NC have a... Yeah, dude, I want to see. Oh, this guy is so cool. This is the guy, man. He does all the boards. Oh yeah. You know what's surprising to me? My Bamboo P1S, it's not even the steppers on there are tiny, man. Wait, Fluid NC doesn't have closed loop? They do have a board that plugs directly into external drive. Well, I don't know what I'm planning on. I just always thought closed loop was really cool. Ooh, a little. Oh, that's cool. Little handle jog. That's freaking cool. Dude, I want that. That thing is cool, man. What is this? Most closed loop drivers do a lot of the position control after the signaling from the control board. Okay. Dude, I'm so happy that I finally dug into this Fluid NC thing. Oh, he's the author of it. Oh. So do most of these no, but wait, what's a Merlin? Cuz I thought Merlin was the what is it called? Marlin. This is the firmware that but does this run on ESP? This is what most of that stuff runs on, right? What's the difference between Marlin and What's up? What's up? What's up? Oops. Because they're both equivalent, right? Oh, STM. Interesting. 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 It's so funny how fractured CNC CNC stuff is. Oh, that's cool. Yeah, see, because there's so many things that where you want a pulse width on the spindle. CNC started to take different paths because the extruder needed more than just to control the laser or the spindle. Yeah, exactly. Well, because Dude, the guy that made GRBL, where is he now? What's that guy's name? It was in the README. Where is he now? Because he's a legend, dude. He's at Lincoln Labs. Dude, why doesn't this work? What is this crap? Whatever. Aerospace engineer. Motor with a heat sensor, right. And the heater with PID control. Yeah. Yeah. All right, I gotta go.